Ionic compounds tend to have the highest boiling points and melting points because they have interionic forces. The attraction between positive and negative ions tends to be very, 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 very strong, much stronger than most covalent compounds. Among the covalent compounds, the boiling points and melting points depends on the strength of the intermolecular forces, and in general, there are some exceptions, but in general, those with hydrogen bonding tend to have higher melting points and boiling points than those with just dipole forces, which tend to have higher melting points and boiling points than those with just London forces. The London forces can be a bit tricky because London forces can be stronger than hydrogen bonding in some compounds or weaker, and so London forces we see a greater range, and so for that reason I'm going to keep my questions in a sort of apples to apples basis. What we would do is we would indicate or note whether or not we would look at whether or not we have ionic or covalent compounds. This one is ionic, these two are covalent. Between ionic and covalent compounds, ionic compounds tend to have higher boiling points and melting points because of the ionic forces. So I would say that the potassium bromide has the highest boiling point. This is number one, or this is the highest because it is ionic. Between these two, I would look at my list of forces to determine what types of forces were present in these two compounds. And one thing that I can say without a doubt is that all covalent compounds have London forces, which we also can call London dispersion forces, which we also can call dispersion forces, which we also can call induced dipole forces. So both of these covalent compounds have London forces present. If that were all that was present, then I would be looking at the number of electrons present, and in general, if you're trying to compare the number of electrons, it's easier to look at the molar masses because you can usually do that more intuitively, more quickly. And since this compound has the higher molar mass, it's going to have more electrons, which means it has stronger London forces. So stronger London forces means I'm going to have a higher boiling point. But besides that, you may notice that this one has an oxygen-hydrogen bond. An oxygen-hydrogen bond means that this compound also has hydrogen bonding present. And again, in general, comparing apples to apples, something with a hydrogen bonding, I might expect to have a higher boiling point because it has stronger forces than a similar compound that only has London forces. So this one would be my second highest boiling point, and this compound would be my lowest boiling point. If I'm looking at these three compounds, I see three very similar compounds. Think back to your Chem 1 days. This water molecule has an oxygen with two hydrogens bonded to it, Lewis structure. There are some lone pairs on that oxygen, so even though I would draw the Lewis structure like this molecule is actually bent, which means that the molecule is polar, and as such, this molecule has dipole forces. First of all, any covalent compound, and all three of these are covalent compounds, any covalent compound has London forces. So I see London forces in all three of these samples. Water is polar, so I see dipole forces in it. And if you recall from your lessons on Lewis structures, H2S and H2SE are going to have identical Lewis structures to H2O because the sulfur and the selenium are in exactly the same group as the oxygen, which means they have the same number of valence electrons, which means their Lewis structure looks the same as long as I don't expand any octets, and you don't in this case. So not only is water polar, but H2S is polar and H2SE is polar. So you can do some of these kind of quickly, especially if you're comparing apples to apples. I have dipole forces in all three of these compounds. If that were it, comparing the fact that they all have dipole forces and they all have London forces, I might start looking at, well, who has the strongest London forces, meaning who has more electrons. And in this case, the H2SE has more electrons. I mentioned earlier, sometimes it's more intuitive to think of molar masses. H2SE has a higher molar mass. That means it's going to have more electrons. So you would expect H2SE to have a stronger London forces, which means it's going to have a higher boiling point. But you would be wrong, because H2O also has hydrogen bonding. Now, it's the only one in this list that has hydrogen bonding. It has an oxygen bonded to a hydrogen. This has a sulfur bonded to a hydrogen. That's not hydrogen bonding. This has a selenium bonded to a hydrogen. That's not hydrogen bonding. The fact that the oxygen is bonded to the hydrogen means that this particular sample will have hydrogen bonding present, and you should probably memorize at this point that water has hydrogen bonding. That's going to be very useful for the rest of your life. And so, since water has hydrogen bonding, comparing apples to apples, that tends to be the strongest force. And so you would expect water to have the highest boiling point. And indeed it does. Water has the highest boiling point between H2S and H2SE. Now I'm down to looking at two compounds that just have London forces and dipole forces. And since H2SE has more electrons, it will have the second highest boiling point. So H2SE will have the second highest, and H2S will have the lowest boiling point.